one differential equation and we have to solve it. The condition y equal to 1 when x equal to 0 is given so that we can find c later on. So let's focus on the differential equation. The first step of differential equation should be that dy should be with all the y's and dx must be with all the x's. So by doing cross multiplication we can do that. So and one more very important point, that dx and dy, both of them must be numerators. Okay, so since we can see that dx is a denominator, it is not acceptable. It has to go to the other side and become numerator. So let me write e to power 2x dy only and bring 4x y square dx to this side. Now x's are not with dx, all of them. This is not. So we will cross multiply and this will become the denominator here. So it goes from here. Similarly, y square is not with dy, so it will go and become denominator here, right? So let me do it cleanly now. This was the case, dy over y square. So y square came and became denominator on the other side. Here will 4x is already on top, no problem, but e to the power 2x will come below and dx. Now dy, dx both are numerators. Dx is with x's, dy is with y. And next step should be to integrate them to find the equation with the help of differential equation. For integrating, let's rearrange this. We can write this as y to the power minus 2 equal to dy, and equal to, let's take 4 out of it, so it will be x e to the power minus 2x dx. So this one can be easily integrated, which is y to the power minus 2 plus 1 over minus 2 plus 1, and that comes out to be y to the power minus 1 over minus 1, and we can write this as to make this positive, it will become a denominator 1 over y, and this minus will make this whole thing minus 1 over I. So this is our left hand side. Let's focus on the right hand side now. And here we can see that there is an algebraic part and there is an exponential part and they are multiplying. So the best way we can integrate this will be by parts. So we will carry out integration by parts. So we know the sequence is LIATE, where we have E as exponential, which is here, and A is algebraic, which is X. So let's label them now. This will be V prime, this will be U. So U and V prime. So the formula for that is integration of u v prime, which is the question right now, u v prime will be u v minus u prime v. If you're not aware how this came about, I have a video on integration by parts. You can scroll my channel and see that how this came about. It comes from the product rule of differentiation. So it's taught in that video in detail. Alright, so we'll ignore the left side down. Now we'll focus on the right side because that is equivalent to this and that will be the solution. Alright, so u is known to us, which is x. So RHS in this case will be x. V prime is with us, but we want v here. So let's carry out v prime somewhere here. I'll have to do it somewhere here. Okay. Integration of v prime, what will happen? Integration and prime cancel, we get v. That means we have to integrate e to the power minus 2x to get v, and which will be e to the power minus 2x itself divided by the differentiation of minus 2x, which is minus 2, and that's it. So we can write, in place of v, we can write e to the power minus 2x over minus 2 minus. Now we have integration and we want u prime. U prime means the differentiation of x in this case. What is differentiation of x? 1. So there is no need to write 1, but just for the sake of understanding, let's write 1 here. And we just found out v, which was e to the power minus 2x over minus 2. Let me write just 2, and our that minus will make this positive. Alright, so now we have almost everything here. X e to the power minus 2x over 2 plus. Now we know the integration of this e to the power minus 2x will again be e to the power minus 2x over minus 2. And we had a 2 already here, so we'll multiply this further by 2. And I forgot to write minus here. So it becomes minus x e to the power minus 2x over 2 minus e to the power minus 2x over 4, right? Alright, and that makes ready our RHS. RHS will be this, which is minus x e to the power minus 2x over 2 minus e to the power minus 2x over 4. And if you remember, this 4 was there in front, so we did not take care of this till now. Now we will put it here, and LHS was minus 1 over y already, and we have to add a c after this. Alright, now let's open this bracket. First, minus 1 over y equal to, when 4 multiplies with this 2 will cancel out, so it will be left with minus 2x e to the power minus 2x. When this 4 multiplies with this one, this 4 and this 4 cancel out, and we are left with minus e to the power minus 2x and plus c. We need to evaluate this c before proceeding. So we were given a situation, let me see again, y equal to something, y equal to 1 equal to when x is equal to 0. So y equal to 1 when x is equal to 0. That's what we will substitute here. Minus 1 over 1 equal to minus 2 times 0 e to the power 2 times 0 minus e to the power minus 2 times 0 plus c. This whole thing is 0 because of this 0. So we are left with minus 1 here equal to minus, and this is e to the power 0 is also 1, minus 1 plus c. Alright, so this minus 1 goes here, becomes plus 1 minus 1 equal to c, and that is 0. That means c is not there anymore, so we are just left with the main equation. Let's go back to the equation which was this one. Okay, so minus 1 over y equal to 4, and now let's do what? Both of them have x to the power e to the power minus 2x, so e to the power minus 2x, let's take common out of this. Both of them also have 2, so let's take 2 also out. So what is left inside? From here I'm saying without c. Alright, so here we are left with minus x. Minus x, this is the only one left because e to the power minus 2x and 2 both are out. And here we'll be left with minus, and e to the power minus 2x is out. 2 out of this 4 is out, so 1 over 2. Okay, so now we have to reciprocate this. Before that, let's make this also a rational part. So minus 1 over y equal to, and 2 and 4 can cancel. 2 e to the power minus 2x, and the LCM of these two will be 2, and we'll be left with minus 2x minus 1. Alright, this 2 and this 2 again gets cancelled out. Okay, everything is falling in place now, and we'll reciprocate this now. It becomes minus y equal to, we have to reciprocate this also, so 1 over e to the power minus 2x, and we have to reciprocate what is here also, 1 over minus 2x minus 1. Too many negatives here, so let's get rid of negatives by multiplying the whole equation by negative 1. So this becomes positive y. This becomes, okay, let's keep it what it is. Rather, we can bring this e to the power minus 2x to numerator to make it positive 2x. And this minus 1 will affect these. Okay, we cannot affect both of them, they are multiplying, so I wanted to make them positive, so it will be 1 over to positive 2x plus 1. And now if we combine this, final answer should be e to the power 2x over 2x plus 1. Question 8. By first expanding this, show that cos 4 theta plus sine to the power 4 theta equal to this. Okay, notice cos square theta plus sine square theta is 1, right? It is a proven identity. Let me write it here. Cos square theta plus sine square theta equal to 1. So if I square this, that means the square of 1 will also be 1, right? So let me write that thing here. So if I expand this by the identity a plus b whole square equal to a square plus b square plus 2ab, it will be square of cos square theta, which will be cos to the power 4 theta, then square of sine square theta, which will be sine to the power 4 theta, and then 2ab, 2 multiplied by cos square theta sine square theta, and that is equal to 1. In the identity, they are asking us to prove cos 4 theta plus sine 4 theta are on the left side. That means this one has to move to the right side. So let's do that. Cos 4 theta plus sine power 4 theta is equal to 1 minus 2 cos square theta sine square theta. This can be written as 1 minus 2 cos theta sine theta and whole square, because I want a square here, so that's why I converted this square, individual square, to the whole of the square. Now we have another identity which will be useful here. That identity is cos rather sine. Sine 2a equal to 2 sine a cos a. This is the identity we will use now. So if I square this, sine square 2a, this will also be squared, correct? So it becomes sine square 2a equal to, so it can be 2 square, the square with this, multiplied by sine a cos a square. So I again gave this square to them individually. This one matches with our output here. Only thing is that we don't have 2 square 4 here, we have just 2. So to make it 4, we can multiply it by 2 and divide it by 2. Now this was 4 sine a cos a square. It completely matches with this one now, this one. So I can write this as sine square 2a, which is correspondingly here, it will be, let me write here, equal to 1 minus sine square 2 theta. And this 2 is extra, so we'll divide it by 2, which is already a denominator. Okay, here is the B part. They said, hence solve the equation, this one. So in place of cos to the power 4 theta, sine to the power 4 theta, we will use the right side, what we got there. What we got, 1 minus half sine square theta. This is what we will use, not the left one. Okay? So, 1 minus half sine square 2 theta equal to 5 over 9. Let's bring 1 to the right side. Half sine square 2 theta equal to 5 over 9 minus 1. So half sine square 2 theta will become minus 4 over 9. Both sides are negative. Let's cancel that out and make them positive. And then multiply this by 2, multiply this by 2, so that this 2 cancels out. Sine square 2 theta equal to 8 over 9. Let's square both sides, square root. Sine 2 theta equal to square root plus and minus 8 over 9. So since they are saying that our domain is 0 to 180 degrees, 0 is here, 180 is here, and in these quadrants it will be negative. Now we have to find the theta, common acute angle for all of them, which will be sine inverse plus minus square root 8 over 9. So let's focus on plus first. Sine is positive here and here, so we'll get the angle for here. Sine is negative in these two, they will get here. So all four quadrants will have some answer. So let's write the first thing first. Sine inverse 8 over 9. 2 theta, the acute angle I get, sine inverse square root 8 over 9, 70.58 degrees. So it is 70.6 degrees. So this angle we'll write here 70.6, 70.6, 70.6 and 70.6. So we'll have four answers. Let's talk about the first one, 2 theta 1. The first quadrant itself will be 70.6 only. So that gives us theta 1 equal to 70.6 divided by 2, which is 35.3 degrees. Second angle, 2 theta 2 will be, let me show you by different color, from here till here. This angle will be the theta 2. So that will be 180 minus 70.6. So which is 109.4 degrees. So theta 2 will be 109.4 divided by 2, which is 54.7 degrees. Okay. Now, third angle. We are still away from our upper limit of 180 degrees. Just 54 we've got. So we'll go to the third one, which will be 180 plus 70.6 degrees, which is this angle starting from 0 again and reaching this line, which will be 180 and plus 70.6 more. So let's find this theta 3. Will be total will be 250.6, correct? So half of this is 125.3 degrees. Number 4, theta 4. 2 theta 4 will be in the fourth quadrant, and that angle will reach from here further till here, which is 360 minus this 70.6. It is less than 360, right? This is what we're going to reach at 360 minus 70.6 degrees. So that will be 189.4 degrees. So theta 4 comes out to be 189.4 divided by 2, and that will be 144.7 degrees. So we got four answers. First answer was this, second 54.7, third 125.3, and fourth 144.7. These are the four answers of the given equation. In question number 9, they have given an equation of a curve and we want to find dy over dx. So for finding dy over dx, let's differentiate it with respect to x. Since y and e to the power 2x are multiplying, both are variables, we will use product rule in this. So y we will differentiate once, we will not touch e to the power 2x, but second time y is untouched and we'll differentiate e to the power 2x. Similarly, in this one, we will use product rule again. So y square prime e to the power x remains what it is. Minus again, okay? This minus applies to both. That's why both are minus. So y square is y square and e to the power x is differentiated. And differentiation of 2 will be 0, so it will be equal to 0. So let's differentiate this one, which will be 1 dy over dx. That is differentiation of y. And e to the power 2x is what it is. Plus differentiation of e to the power 2x will be 2 e to the power 2x, and then we have y, which was here. Minus differentiation of y square is 2y dy over dx multiplied by dx minus y square, and differentiation of e to the power x is e to the power x, no change. Now let's take dy over dx common from these two. So dy over dx e to the power 2x minus 2y e to the power x. Yeah, this, alright. And let's bring these two to the other side. I'll write this one first because this will become positive. Equal to y square e to the power x, and this will become negative minus 2y e to the power 2x. That's how we'll write it. So dy over dx, this part will become a denominator on the other side, will be y square e to the power x minus 2y e to the power 2x over 2 e to the power 2x rather, minus 2y e to the power x. And our format is not matching with what they want. So what we can do, all of them have e to the power x. Let's take e to the power x common from numerator first. So we'll be left with y square minus this minus, and e to the power x is here, so 2y e to the power x. Let's take e to the power x common from the denominator as well. So it will be left with e to the power x only, and this one will be minus 2y. And they cancel, and now this solution is near to this, but what is there? You can see that all of them are correct, but the signs are opposite. So to get that one, we can multiply this by minus 1, multiply down also by minus 1, and all of them will change their signs and we'll be getting what they want. 2y e to the power x, and this y square will become negative over this 2y will become positive, and e to the power x becomes negative, and now it must match with what we get. Yes, it is matching now. Next, find the exact coordinates of the point on the curve where tangent is parallel to y-axis. So whenever a tangent is parallel to y-axis, that means this is the tangent, that means the curve is something like this, right? And vertical tangent means it is undefined. Okay, we can't find its gradient. And how can this become undefined? It will become undefined if the denominator is 0. So logic is, if you say 3 over 0 and put in your calculator, you will see undefined. If you see 11 over 0, undefined, and it's constant over 0, it will be undefined. So what is common in them? Denominator is 0. So we will make denominator equal to 0, and that will give us our answer. So 2y minus e to the power x equal to 0 for undefined dy over dx, and it becomes 2y equal to e to the power x, and y is half e to the power x. They're saying find the exact coordinates of the points on the curve. Okay, so y is e to the power x. That's what we'll do here. And let's put this in our curve now. Okay, so in this equation, we will substitute y is equal to half e to the power x. So this y becomes half e to power x multiplied by e to power 2x minus the y square will also become half e to power x square e to power x, and that is equal to 2. So let's see, this becomes e to power 3x over 2. This one will be squared, so it will also be, okay, let's do it one by one. 1/4 will be the square of half, e to power 2x will be the square of this, and e to power x equal to 2. So it becomes e to power 3x over 2 minus e to power 3x again over 4 equal to 2. And if I subtract, it becomes e to power 3x over 4 equal to 2. Yeah, because this is half, half minus 1/4 is half, 1/4, sorry. So 1/4. So cross multiply, let's complete it here. E to power x, 3x rather, equal to 8. 3x equal to ln 8, x becomes ln 8 over 3. Let me make some space for this here so that we can get the exact value here. So this can be written as x equal to 1 over 3 ln 8, or this can be written as ln 8 to the power 1/3, which is cube root. That becomes ln 2. That is the x coordinate. So let's use this x coordinate to find y, which was here. Y equal to half e to power ln 2. Whenever we have e to power ln, they can neutralize each other, and we are here with half times 2, 2 and 2 cancel, 1. So the coordinates are ln 2, 1. Question 10. With respect to origin, the position vectors of A and B are given. OA is 1, 2, minus 1. This is A, this is origin. I'm not drawing the actual axis because it is so difficult, because in 3 dimensions it is difficult to show the positions of vectors. So B is, OB is 0, 3, 1. I'm writing them in form of coordinates, right? Position vectors also become the coordinates of the head. So that's why I'm writing them in form of coordinates. So these are the vectors we're talking about, OA and OB. Alright, find a vector equation of the line L passing through A and B. So let me draw a line through A and B. This is the line they're talking about, and change its color. Okay, this is the line, and we have to find its equation. So equation, rather vector equation they're saying, right? So vector equation of a line should have a point first. So what is the point on this line? We can use either this or this. Doesn't matter which one you use. We can use any one. Let me choose the one with 0, so it will be easy to calculate later on if it is needed. So point is 0, 3, 1. All right, and I need a vector. And the vector AB we can find. So let's find vector AB. So vector AB will be the head vector, which is OB, position vector of B, minus position vector of A. So OB is 0, 3, 1 minus 1, 2, minus 1, which will be 0 minus 1 is minus 1, 3 minus 2 is 1, and 1 minus minus 1 will be 2. This is the vector, and now we can write the vector equation of this particular line. It should be a point first. Point we already know, 0, 3, 1. So vector equation of AB will be 0, 3, 1 point plus the parameter we need. Let's say the parameter is A, and it is minus 1, 1, 2. The vector AB. This is the equation, and we can write it equal to R equal to. Okay, now the B part. B part says the point C lies on line L such that AC vector is 3 times AB vector. So let me copy that picture here. They're saying that it lies, C lies on AB, and 3 times AB is AC. Okay, so that means this line goes very, very, very long. Let's say somewhere beyond this, and such that this particular length, if it is 1, this length is 2 up to C. That's how it becomes 3 times. Okay, on this picture it doesn't look like, but yeah. AB times 3 is AC. That's what it is. Alright. Find the position vector of C. So we have to find the position vector with reference to origin again. So that basically this is one we want to find out. This is AC. We have to find the position vector. Somehow, if we find the coordinates of this point A, B, C, that will be the position vector. As we learned earlier that the head, coordinates of the head is actually the vector of, position vector that is, of that point. So somehow let's try to find this particular vector. And the best way to find these coordinates is to take help of these ratios. How? First we'll find what is the difference between the x coordinate of this point and this point, which is a minus 0. And this length, though it does not look like because there is a scarcity of the space, but this length is twice this length. So the x coordinate difference of 0 and 1 will be half of this. In other words, a minus 0 will be twice of the difference between 0 and 1. 0 minus 1. And that's how we can get A. A equal to minus 2. Similarly, B minus 3, which is the difference, this one, between y coordinate of this and this, will be twice of the difference between 3 and 2. 3 minus 2. So B will B minus 3 is, subtract this one, 1 times 2 is 2. So B becomes 2 plus 3, which is 5. Now C's turn. C minus 1 will be twice of 1 minus, we have minus 1, right? Yeah, minus 1. So that is 1 plus 1, 2 times 2 is 4. C minus 1 is 4. C becomes 4 plus 1, that is 5. So now we know the coordinates of C very clearly. They are minus 2, 5, 5. So the position vector of C, which is OC, will be in column notation. If you want to write, it is minus 2, 5 and 5, or if you want to write in algebraic form, it will be minus 2i plus 5j plus 5k. This is the position vector. Now C part. It says that find the possible position vectors of point PL such that OP is square root 14. So I have copied the picture again here. We want a point on P. So let's say point is here, P, right? And OP, this distance has to be square root 14. So let's give some alphabets to this as well. And let's give it R, S, and T. These are the coordinates of P. Now, since this P is lying on the line AB, it will satisfy the equation of AB. Let's go back. What was the equation of AB? That was the vector equation 0, 3, 1 and minus 1, 1, 2. 0, 3, 1 plus a minus 1, 1, 2. And since RST is on the line, it will be equal to RST. So the parametric equation becomes R equal to 0 plus 0 minus A rather, 0 minus A. S becomes 3 plus A. This is 3 plus A. And T becomes 1 plus 2A. Right? Now they're saying the magnitude of OP is square root 14. So we'll have to find the magnitude of this particular vector, which is nothing but the combination of these. And the magnitude square root 14 will be equal to the square root of the x part, which is minus a in this case, squared, plus 3 plus a squared plus 1 plus 2a squared. This is how we find magnitude of a position vector by squaring the x, y, z coordinates of the head. And that will be, let's square both sides. So 14 equal to a squared plus, square this one, 9 plus a squared plus 6a. Similarly, 1 plus 4a squared plus 4a. So let's collect everything to the right side. 0 equal to a square plus a square with 2a square plus 4, 6a square. Then 6a plus 4a and nothing else is 10a. Then we have 9 plus 1, 10, and minus 14 when it comes to the right one, minus 4. So let's divide all of this by 2 so that we get a simpler quadratic equation. Okay, it becomes 0 equal to 3a square plus 5a minus 2. So let's find the values of a by factoring. You can use your calculator, but I'm factoring this one. So the first answer of value of a will be through this 3a minus 1 equal to 0. Second will be a plus 2 equal to 0. This gives us the answer straight away, a equal to minus 2. And this will give us a equal to positive 1/3. So since we have the values of parameter for there are two values for that parameter. For p, let's substitute them into the parametric equations of RST we just found earlier, and we'll find the coordinates of p, which will be the position vector of p, OP rather. So let's substitute a equal to 1/3 first. So it will be minus 1/3. If I do it here, it will be 3 plus positive 1/3. That will be 10 over 3. Third one will be 1 plus 2 times 1/3. 1 plus 2/3 will be 5 over 3. So the first possible position vector of OP is minus 1/3, 10 over 3 and 5 over 3. Or the second one could be, let's use it here, when a is minus 2. So r equal to minus 2, which is positive. S will be 3 plus minus 2, which is 1. And t equal to 1 plus 2 times minus 2, which is minus 3. So this becomes 2, 1, minus 3, second possibility. Question 11. The equation of the curve is y equal to square root 10x between 0 and pi by 2. Express dy over dx in terms of 10x, okay? And then verify that it is equal to 1 when x is pi by 4, alright? So let's change this equation into another format, which is y equal to tan x to the power half. And we will differentiate this. So dy over dx equal to, it is a power of a function, so half comes in front and becomes coefficient. And the exponent of 10x goes down by 1, minus 1. And further, we multiply this by the differentiation of what is inside. So what is differentiation of 10x secant square x? That's what we do. So let's change the format. 1 over 2 and half minus 1 is negative half. So 10 to the power negative half, to make it positive, we'll make it a denominator. Okay, as secant square x is equal to 10 square plus 1. Why did I change? Because they said in terms of 10x we want. So we want 10x and 10x. So it will be 10 square x plus 1 over 2, and we can write this as square root 10x. Yeah, this half can become the square root of the whole of it, and this is what dy over dx is. Now second part is that we have to verify if dy over dx equal to 1. So let me do it here. So tan square pi by 4. You can write here when x is 1 over 4 pi, which is pi by 4 in other words, okay, plus 1 equal to 2 square root tan pi by 4. And tan pi by 4 is very popular kind of angle. Why? Because it is equal to 1. So tan square 1 becomes 1 square plus 1 divided by 2, and tan pi by 4 is again 1. So we can say 1 square plus 1 is 2, and 2 square 1 is 2. 2 and 2 cancel out. Yes, it is equal to 1. Let's look at the second part. What are they talking about? They're saying the value of dy over dx is 1 at another point. So it is 1 here at pi of 4. This is 1 at another point, they're saying, which is a. Show that t cube plus t square blah 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 when t is sine a. So each t represents tan a, not sine a, tan a at this particular position. Okay, so what was our differentiation again? Let's do it. It was tan square x plus 1 over 2 square root tan x. This was dy over dx, and they said it is equal to 1 at 2 places. Okay, so one of the places we already know is pi by 4. Second we have to find out, that's the one. Let's cross multiply first. Let's bring it to this side. So it becomes tan square x plus 1 equal to 2 square root tan x. Then we can square both sides so that we get rid of the square root. Let me continue it outside this space. So the square of this will be tan to the power 4 x plus 1 square will be 1, and plus 2 times tan square x, a square plus b square plus 2ab. That's what I use here. The right side will be 4, and square root will cancel out, 10x. Alright, let's bring everything to the left side. It becomes tan to the power 4 x plus 2 tan square x minus 4 tan x plus 1 equal to 0, and it does not match with this if we write tan a. So we know that this will be true because we equated equal to 1. If you remember here, we equated it to 1. So that's why this equation will be true for a also. So let's do it. Tan 4a plus 2 tan square a minus 4 tan a plus 1 equal to 0, which we can write it as 2t4 plus 2t square minus 4t plus 1 equal to 0. We know that one of the solutions of tan dy over dx equal to 1 is pi over 4. We already know that. Okay, so in that case tan a is tan pi by 4, isn't it? So which is t equal to 1, and if I want to write this as a factor, it will be t minus 1, right? So that means one of the solutions I have to remove from this, and I know that solution is t minus 1, so I will divide this polynomial by t minus 1 so that I get the remaining part for the other roots. So plus 2t square minus 4t plus 1. Okay, and I have to write t3 here, so this becomes t4 minus t3. There is no t3, so let me write here minus t3, and we'll subtract. This becomes negative, this becomes positive, they cancel out. So I'll write t cube now here, which is positive, plus 2t square minus 4t plus 1. Now I need to make it t cube t, so I'll write t square here. Am I on the right track? Yes. T cube minus t square. This becomes negative, this becomes positive, cancel out. 3t square minus 4t plus 1. Next will be plus 3t square minus 3t. Negative, positive, cancel. Minus t plus 1. And minus 1 will multiply, minus t plus 1. And they cancel. So this is our second answer. T cube plus t square plus 3t minus 1, and we already had a t minus 1 equal to 0. This answer is already with us. The second one is the one they wanted. This is also equal to 0 when t is tiny. Yeah, t cube plus t square plus 3t minus 1 equal to 0. Got it. Okay, let's move on to the next one. And they're saying use the iterative formula to determine a correct to 2 decimal places. Okay, we need to use this iterative formula, and they have not given any starting point. So let's look at the graph and get an idea. This value is between 0 and 1 over 4 pi. Okay, so we'll find a value in middle of 1 and 1/4 of pi. All right, so our starting will be 0 plus 1/4 of pi over 2. This will be the starting point because we know it is between these two values, which will be 1 over 8 pi. In decimal, it is equal to 0.4, almost 0.4. So let's start with 0.4 and we'll get it. So A2, which is next value of n plus 1. So this will be my A1, the starting point. Okay, so I'll use this one inside, equal to tan inverse 1 over 3, 1 minus tan square 0.4 minus tan cube 0.4 and students. And they want it for 4 decimal places, so I got it as 0.2436. Now A3 will be same with the angle 0.2436 now, and we will repeat this unless we get a specific parameter, and that's what I will talk about completing this process. Now I stop. And why do I stop? Because they said that we want answer to 2 decimal places here. For 2 decimal places, on each step I rounded them off to 2 decimal places. It gave me 0.24, 0.30, 0.28, 0.29 and 0.29. When you get same digits in 2 consecutive attempts, as same 0.29 here and 0.29 here, and our answer is A equal to 0.29 as a result.